welcome each one of you to this morning's event organized by Mysore Open Forum on the topic of, as you can see here, responsible AI in the times of generative AI by my dear friend, Dr. Carolyn, who is Professor Emeritus, Faculty of Computer Science, Dalhousie University, Halifax, Canada.
Okay, what a pleasure to be here. It really is a great pleasure. So my goal today is not to dive too deep into the computer science algorithms involved, but to look more at the impact of the latest version of artificial intelligence that we're all reading about. First thing I saw when I arrived in India was a whole page on AI. I thought, oh, I don't need to tell anybody anything. But I thought that they did a great job, but I don't know what day it was. The Times. It was the day I arrived, and it had actually great explanations of what these algorithms were for, as opposed to this is going to change the world, we'll all be out of jobs, all this stuff. So I thought, well, okay, we're good to go. So I'm going to focus on, I need a little timeline to where we are now, what the status is right now, and then what I see as issues that we really need to respond to before they are de facto done. So from my perspective, you'll see that these current generative AI things came to the market, big splash. No one had really thought through what the impact might be. And we're coming up for another generation, and hardly anybody has actually stopped to say, well, maybe we could be a little proactive on some of these impacts. So I'll try and walk through that. And then there's a little homework for everybody. What your roles might be and how you might actually engage in this further. So of course we had a little technical problem here getting up and going, so I'm hoping it's working now. So I won't repeat the history here, but Shalini did a great job. So this is the class at DRTC on Malleshwaram, downtown Bangalore, that we came, Mike Shepard and I came to spend a term there. There were 5 professors, 10 students, some staff, and then Mike and I. So you probably can't find us. That's me, and that's Mike. And this little dog is called Popsy. We called it Popsy after one of Gopinath's faceted schemes. Anyway, and then that's where it was in Malleshwaram. And then they moved to ISI campus as DRTC. And particularly Mike has spent a lot of time at the Myra School of Business here over the years. And I've only gone there enough to give talk and have mango trees. So I guess we'll go to the next slide. Okay, so I'm going to talk about generative AI in a text context. So I'm not going to worry about images, voice, art, although now that I see we have an art person here, I probably should have. But text is my area, so I'm going to stick to what I know. I will talk a little bit about what generative AI is and how we got there. And then this notion of responsible AI. Who benefits? Or as we would say in Latin, cui bono. Who's benefiting right now is largely the 5 companies who are producing this. So keep that in mind. And then I'll talk about these emerging issues and how we really need to step up before that's completed. And then, as I said, your homework. Can I have the next? Okay, brief timeline of natural language processing. So I don't want anybody in the room to think that generative AI just appeared. 5 years ago, 6 years ago, somebody thought this is a great idea, I'm going to go and do it. Not true. From the 60s on to 2000, these algorithms were developed and used for different things. So in 1950s, we were worried about natural language translation. I can tell you it didn't work very well, but algorithms were built. In the 60s, we started to do more algorithms in natural sounding text. So it sounded like people, and I'll show you an example. And this is when they called the first AI winter. So there was a big hype, which you're familiar with because we're going through one right now. And it went through, but the research continued. So the notion of the winter, well, you don't really get winter. But in Canada, all growth stops in the winter. It's too cold. And so we have this sort of mystical AI winter. But actually, all of the algorithms and all of the work continued at the universities. There just wasn't big funding. So companies weren't funding it. They couldn't see what good it would do them. Governments were saying, oh, yeah, that's fine. That's, whatever. When you're ready, I'll think about funding. In the 1970s, which is when I started, they started to think about grammar. So if you're going to do natural language processing, you need some underlying grammatic structure. And that's when that really started, and we started talking about semantic networks. And in the 1980s, we started to develop expert systems. So they had ontologies, or graphs that had nodes of entities or ideas, and then relationships between them. So you can think, skeletons, we've got broken arms, it's a relationship to your skeleton. Where is it? What's it connected to? I don't know if you say this in India, but we have a song that says thigh bone's connected to the knee bone. And that's what the ontologies do. Expert systems, and we'll see why they weren't more problematic. In the 1990s, we went into statistical models. The data, we had enough data that we started to think, there are populations in here. Let's do some statistical analysis. 2000, you can see the connection between case grammars, ontologies, and language modeling, right? So these are all connected. And then in 2010, heavy-duty work started on this notion of pre-trained models of language usage, which developed about 2016, 17, it actually became viable, which we need to think about. And now in 2020, we're in the world of chat GPTs, large language models. I'll take the next one. Okay, so I'm a kind of history buff, so you have to put up with this. So this is John McCarthy in 1956, and he was the one who came up with the term artificial intelligence because he was doing the first artificial intelligence conference. Nobody really knew what it meant, but people showed up in throngs. And he really thought his idea was that the machines were capable of human-like processing. And so the work from 1956 to 2016, that's how long it took to get there. So, and this is my favorite quote ever. Someone asked him, when would this happen? He said, unquestionably, somewhere between 5 and 5,000 years. So I've done a lot of work for the government on quantum, and I use this quote all the time because, the companies all say, 3 to 5 years. And so I would say, well, 3 to 5 to 5,000. So we don't know. Don't know when it's really going to happen, and so we need to look at it as the community that we have now and what's going on. Click again. This is, click one more time. Okay, this is Joseph Weizenbaum, and he actually wanted to try out responding to users in natural language and not just producing it. And this was 64-ish when he did this. Can we have just one more? Okay, so here's the example. Eliza was a therapist. And so Eliza says, please tell me what's been bothering you. And this was all done remotely, right? And the user says, everything. Eliza says, well, tell me more about that. So you can, it's not really, it's picking out some words and then having a canned response, which is slightly different from a chat GPT, which is on the fly coming up with a response. Does talking about this bother you? And you says, no, oddly enough. And why? No, right? It goes on. And this, people couldn't believe that this wasn't someone typing at the other end. And so I use it as a great example of the reason this works, natural language interaction works, is because it's presented in a way that we have confidence. So I won't repeat the history here, but Shalini did a great job. So this is the class at DRTC on Malleshwaram, downtown Bangalore, that we came, Mike Shepard and I came to spend a term there. There were 5 professors, 10 students, some staff, and then Mike and I. So you probably can't find us. That's me, and that's Mike. And this little dog is called Popsy. We called it Popsy after one of Gopinath's faceted schemes. Anyway, and then that's where it was in Malleshwaram. And then they moved to ISI campus as DRTC. And particularly Mike has spent a lot of time at the Myra School of Business here over the years. And I've only gone there enough to give talk and have mango trees. So, so I guess we'll go to the next slide. Okay, so I'm going to talk about generative AI in a text context. So I'm not going to worry about images, voice, art, although now that I see we have an art person here, I probably should have. But text is my area, so I'm going to stick to what I know. I will talk a little bit about what generative AI is and how we got there, and then this notion of responsible AI. Who benefits? Or as we would say in Latin, cui bono. Who's benefiting right now is largely the 5 companies who are producing this. So keep that in mind. And then I'll talk about these emerging issues and how we really need to step up before that's completed. And then, as I said, your homework. Can I have the next? Okay, brief timeline of natural language processing. So I don't want anybody in the room to think that generative AI just appeared 5 years ago, 6 years ago. Somebody thought, this is a great idea, I'm going to go and do it. Not true. From the 60s on to 2000, these algorithms were developed and used for different things. So in 1950s, we were worried about natural language translation. I can tell you it didn't work very well, but algorithms were built. In the 60s, we started to do more algorithms in natural sounding text. So it sounded like people, and I'll show you an example. And this is when they called the first AI winter. So that each other, hit the button, off you go somewhere else. Can't imagine doing that in 1970, I can promise. And all of a sudden, we have distributed input. We can all you can go home and put stuff on the internet and it will be indexed. And so we've got a broader range of data coming in and a much broader range of people who can use it. Okay, that's not me. This is a 1996 cover of Time magazine. And why I think it's really interesting is that, so there was hype in the 60s, hype in the 90s, all about can machines think? And what's the hype right now? Can machines really think? So I'm sticking with my 5 to 5,000 here. So what happened here? What really happened is that all of a sudden the neural net algorithms, the algorithms that are used based on huge data sets, started to actually work because they were all of a sudden built not for one case, but for whole languages, right? So it's one thing to talk to somebody in medicine. It's another thing to talk to people in medicine, science, arts, school kids, grandparents, right? So it's a whole different algorithm. And computing became large scale. Supercomputers, well, your phone is better than any computer in 1980, I can tell you. So there was huge distribution of computing power, large computing facilities, and immense amounts of data. So all that data on the web becomes input to these algorithms. So huge, huge, which we'll get to again. Okay, so I want to pivot to generative AI. So that's the path of AI, which is underlying all of this. It's just a set of algorithms. Okay, so the difference here is that rather than retrieving or manipulating data that's there, it's to actually create something new that wasn't there. Now you could argue that a summary might be in that class, but I don't think they would buy that. So creating art, ChatGPT, it's creating a response that's not copied from anywhere, right? So they're actually generating on the fly. And so they learn the patterns and structure of the language from training data, which is why you need so much. They're using probabilistic. It's, as I said, a word occurs very infrequently, we don't care about. Occurs too often, we still don't care about it. It's the statistics of all those words in between and which ones they come before and after the most number of times. So it's a statistical analysis, which will come later. And the key here is that they generate understandable and convincing results. It sounds like there's somebody at the back, like Eliza, typing in an answer for you, some knowledgeable person explaining quantum to you. Now you can see that this becomes a problem if you're reviewing academic articles or reviewing funding grants. So who wrote this? A ChatGPT or a professor? And if it's a professor, if it's ChatGPT and they're asking for $10 million, do they actually have the right background? Right? Is the methodology appropriate? Hard for a reviewer to know what that is. And so my little example, okay, here's, I have to take this with me. Never mind. I put in this little query. I need background literature review for information retrieval. Perfectly understandable. I'm just going to start to read that. Here's the response. Certainly. Hang on. I've got an answer for you. I can't quite read it. Okay. So a literature review reveals the following points, and they're all valid, except for they're from being in the area, from a limited view of information retrieval. They sort of got stuck in the 80s and 90s with Gerald Salton and other people, and then the stuff happening in the last 10 years didn't really show up. And I'm not miffed because they didn't quote me. They just didn't quote. So if you didn't know the area, you wouldn't realize that actually it stopped short of what you really wanted to know. But you can see, and it goes on and on. It's nicely structured. It's got different points. It's come up with a structure for itself. What it has seems reasonable, but it's convincing text. It's great. But I did the same search in Google. So Google is now halfway between simply document retrieval. Here's 145,000 documents that have those words, to actually sort of somewhere in the middle, what are other questions that you might ask? And actually, I use that a lot. I put in my query and think, oh yeah, I should have asked that. So it's got this sort of halfway between generative AI and what you have been doing for the last 10 years on internet. So somewhere in the middle. And I think depending on your task, one view gets you farther and the other does something else. Okay, so let's just take a quick look at large language models, LLMs. Everybody says AI, LLMs, so now you can take that home and surprise your family. So the first thing you have to do is to build this data set. And they're called tokens. A token could be a word. It could be a sequence, a part of a word. It could be just a couple of letters. So if you think of a word like searching, it's search they want, not the searching. So the ing would be stopped from a token. And there are trillions. That's a big number. We mostly don't have trillions of anything, but trillions of these in order to make this work. And then they train that data to build up statistical relationships between the tokens. And they give different weights because it's a neural network, so some levels will have more weight on them. We don't care. And then it will generate text based on a prompt. So I need research background on information retrieval. That's my prompt. So it will go in through that view and build an answer for me. Really important that we understand that the data that has been input and the data that is trained and the algorithm to get it out is completely blind to biases and inaccuracy in the data. So again, just keep that in mind when we look at it. And what it's essentially doing is just figuring out what the next word would be in this answer. You think, well, that's kind of short-sighted, but it seems to work. But that's what they're doing. They're not actually thinking about what you asked. They're predicting the next word in that context of what you asked. Okay, so there's good news and bad news. The good news is it writes general text in response to an explicit prompt. So the convincing nature of the text doesn't matter what your prompt was, it still sounds like well-formed and in some sense sensible text. It builds its own sense of confidence because it sounds like your neighbor talking to you. And so you say, okay, I know Shalini. She would have told me that. I would believe it. So it's compelling. And it's particularly good at summarizing areas and high-level output. It's not quite so good at detailed stuff. So it's not so good at background literature reviews, if you're an academic in particular. So covering all the parts of an area, because the language may not always be the same. So we were talking yesterday about the difference between British English, Canadian English, and Indian English. The structure is pretty much the same, but there are many, many words and constructs that are baffling if they come at you. And so it depends where that text comes from. And it's particularly difficult for it to recognize if a theory that's in the text, in the data set, is not valid. How would it know? It's just language, right? And so it's not good at projecting in the future. It's based on historical use of text. And so you're saying, well, what's going to happen in 5,000 years? It's like, oh, I don't know. Joe over here said this is going to happen. And all the AI people say, don't worry, because it'll be done in 5 years. So it's not good at that. And it's not good at methodologies, because there's a value component to that. Okay. Okay, so here's a simple example, really simple. This was done, Polly Allen, who was working for Google at the time. It was news that they created and put out. So protection, hot car law, protection for children and pets requires bystanders to act, and it's got a fine, how much you would have to pay, what you're supposed to do, etc. Can I have the next? Unfortunately, there was no fine, and it left people not knowing whether they should break into the car or not. And if they had broken into a car and there wasn't a child or a pet in it, who's responsible for the damage, right? So it actually could cause harm, but it was not all that stuff, like almost all of it, had nothing to do with reality. And so I like that example because it made me skeptical reading my newspaper for a couple of weeks. Where's that going? Okay, so what can go wrong that we care about, that we need to be really aware of? One is it's called transparency, explainability, and hallucinations. So transparency means that, can you tell me, so you gave me this article, well, I'd like to know exactly what law is this? Who said that, what's the citation for that? No idea. The system has no idea, because it took all the words and dumped them into this system without any connection to where they came from. If you think of the American election, I won't go farther, but you can imagine that there's two different languages going on. Explainability is, well, if I read an article, I think, well, I'd like to know how they got to this conclusion. What's their logic? What's the logic for coming to that conclusion? That's also impossible. It's language, next token, right? So it's difficult for a user to understand how they got there, because it's not, you can't reverse engineer the answer to go back to the logic. Okay, you came from here, oh, I understand, whatever. And hallucinations, again, you can take that word home. It's just fake data. So the results are either incorrect, as my story about the pets, or they're just fabricated, which is even worse. They're just made up. So I think we have a couple of examples. So here's the why. So keep this in mind. The tokens are not connected to their source. The output is based on previous use of the language, not in understanding in any way we would. There's no ontology in there. There's no connection. There's no relationships. And the notion of an answer being correct or incorrect is not there, right? So it's back to the user to figure it out, I guess. Okay, so this is your take-home message. It's called a stochastic parrot, and that is that it's just using statistical data to mimic English language, which if you have a pet parrot, does anybody here have a pet parrot? No, and then I'm safe with this. If you, if you had a pet parrot, it would mimic words but not understand them. And so Oliver Brown wrote, LLMs are wired to make plausible predictions, not report accurate information or share the user's goal. So they don't know what you're looking for or whatever you put in the prompt. If you didn't put in something that resonated with its language, you would get fantastic results. Just, you don't want them. Okay, so that brings us to this whole notion of responsible AI. And this started around the world, I'd say, about 2017-ish. And it's because the AI algorithms were starting to be used seriously, and there was a buildup of the hype of them. And there was no notion of the human-centric part. And so, it's the who benefits here. So if 5 big computing conglomerates own this technology and those data sets, what about all the data? Where'd they get that data? It's your data, it's my data. Every time you go on Facebook, every time you use Gmail, whatever, that data is all scooped up. They get the benefit, not the people who are using it. So we need to think about that. But I just put this up to give you some sense of the worldwide action. It is becoming, however, it's largely at the point of passing sort of regulations. Sort of in Canada, it's the ADA and AI Data Association view of it. And what it essentially does is say we need to make sure it's not biased, it's not inaccurate. Okay, it's a great list, which I think if we go to the next, we'll see it. Yes. But we can say all we like, but how are you going to implement it? Right? So if one country has a set of regulations on data and the company doesn't like it, all they have to do is move to another country that doesn't have those restrictions. And almost no countries, there's a movement in Europe to actually have fines, but if you violate some principles. However, they have no mechanism for ensuring that there's compliance to the laws. So it's what we would call in America the Wild West out there. So these are all the responsible AI that we have right now are largely based on this set of human-centric principles. So the idea of responsible AI is to look at it from the perspective of communities and people. What's the impact on them? What's the values for them? As opposed to just the companies doing it. So we talked about that. Fairness and inclusivity, so language is quite different for and the use of languages for parts of society that aren't active on the internet, so they're not writing documents, so it's not getting in the data set. Bias is a big problem. And my favorite, of course, as an administrator, is accountability and governance. Like, we can make all the proclamations we want. How are we actually going to make it work? Okay, here's an example for you of inaccuracy. So the question was, does this medication interact with another one? Answer, take the two medications together, no adverse effects. Unfortunately, there are and may be in your case. Well, okay, I think I'm calling my local doctor. So that's a good example of it, and I think I have another one. Hallucinations, oh, you have to hit again, I think. Okay, there are two here. The first one is from New York attorney, used Gen AI to conduct his legal research, went in front of the judge, and the judge says, out of here, right? We don't take this. 6 of the precedences were bogus and false that he got from Gen AI. And falsely cited things in legitimate legal databases. Not to say the least, the case was tossed. And in PubMed, which I take more seriously even, they were looking at information on these drugs with pump disease. And the response was, gave a lovely answer. It was a great answer. It had citations with PubMed and the IDs. Unfortunately, the titles of these articles were fabricated, and the PubMed IDs were actually associated with completely different articles in the PubMed data set. So it goes back to it's composing an answer based on the language and the statistics of the language, not about the ontology or the background of the area. I'm going to take off my jacket. I'm from Canada. Okay, so now let me just move into the notion. And so there was a big study done in 2023. Okay. And it was in pharmaceutical questions, and they gave these health people, they did 39 medical searches. 10 of them actually gave reasonable answers. 29 gave dangerous answers. And 21 cases had fabricated references when they were asked and they searched it up. So here was one of the prompts, in which case it responded with a single conversion rate of these two drugs. But in actual fact, there is no conversion rate. There is no agreed upon rate. And 2 of them in that one piece were there were citations from medical organization guidelines which didn't exist. So I have a student working on this. If you look at an answer, I want to know right down here, what's the probability that this is correct? How much confidence do you have in this answer? If it's 20%, oh, okay, that's good to know. If it's 99%, 90%, I say, okay, well, I can go with that. But there's no indication here, right? You're on your own. Okay, so those are the issues that the current responsible AI are dealing with. So if you get bored, this week, and you go and look at the Indian government has a new one, so you could go look at that. You'll see that their focus is on those issues, largely. A little bit on accountability, but not very much. And that's in reaction to what's already happened. So that's very much legal framework. You work on precedences of things that have already happened, and then you try and close the gate. My perspective on this is, right now, we need to figure out what's coming down the road at us, and we need to have responsible AI guidelines that will be put in place before these are just de facto. That's just the way we do it. We can't do too much with what we have because it's there. They're not going to dismount it. So we could make it more transparent, we can make it more obvious of whether this is correct or not. But going forward, we need to look at it. And I'm going to look at these 4 issues: data harvesting, the computing infrastructure, environmental impact. Almost nobody's looking at what it's doing to the planet while we're trying to save the planet over here. And accountability, which is going to be a big issue because sooner or later people are going to sue somebody. I don't know who, but they will. Okay, data harvesting is a really interesting thing, and I think it's very much in your best interest to at least understand what's going on. Currently, they need these huge data sets, and they double every 6 months the kind of data they need to feed the new algorithms. Currently, there's 3 trillion. I made these slides maybe 2 months ago, a month ago. There's probably 4 trillion as we stand here. All of the new data available on the internet will be completely used up. It's not coming in faster than they're using it, but 2026. So there's a huge movement in the research of these companies to create synthetic data to go in the data set. Okay. I see some people think that's not a great idea. Well, and it's not a great idea because then you're building in biases. You're using historical, more weight on historical things, different dialects, different ways of looking at things, different languages, and it's a feedback loop, right? Just, okay, I'm good. You said I was good, I'm good. It's really probably not the best way to do it. And the highest quality has always come from published material. So books, papers, things like that. But of course, there's not enough of that. So the emerging issues are, where do we get other sources of data? Well, let's see what Google did. Google opened up, even though you all signed that you checked it, that they weren't going to use this data for anything else, anything that Google owns, that data is now being scraped immediately to go into this data set. So everything that they have. Meta, the same. Facebook, I've deleted all these apps. I will tell you, you can't get a hold of me hardly at all. Because they're going to make money on it, and they're not going to give me any, and I'm not sure what they're going to use it for. Anyway, all of YouTube, they've now taken all of the YouTube, and if you look at the little thing you checked, it says it will not be used for commercial purposes. But they translate the video language from all of those YouTubes to put into the data set. Okay. But we need to think about that and what's the impact on that, and can you stop it, or at least be more careful with what you do. And remains this English language focus. And primarily English, French, kind of Canadian. That's okay with me. It's just not okay when even you look at English throughout, as I said, Britain, India, Canada's not the same. If you go north to south in North America, the language as you go south changes dramatically. The words that are used, the structure of the sentences, the vocabulary is different. There was somebody here from Texas. the Texas guy? Yeah, he can respond more on that. But it is, so that all gets in there and is treated as though it's all the same. There are biases, particularly historical biases in the language that's used. So women, small groups, minorities. It really is not accounted for in the data, and it's certainly not accounted for when the data comes out. And I would stress the last point, the current business model is maximizing profit for a handful of companies and minimizing the cost. So there we go. I don't have any solutions, sorry. Computing infrastructure. This is a big problem. Okay, these trillion word token systems with 3 trillion 10 times 10 to the 14th connections between all of these tokens. Well, that's not your phone, right? It's a huge, huge data set that they're working with. And that means that they're going to have to build supercomputers to do this. They need to have super interconnection between these very large data sets. It's a slightly distributable but not totally distributable problem because you can't do all those calculations going over bandwidth. So the computing requirement is about 8 times a year currently. The cloud, Microsoft is putting in $1 billion a year. Blah, 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 blah. And the current short-term projection just for computing infrastructure is $200 billion this year. So think what you would do with $200 billion. Would be great. Okay. Oh, sorry. There's the graph. You can see it sort of chugged along, and then all of a sudden, 2015, this is the amount of computing we need to train it, not to use it, just to train it, and going faster. Okay, sorry. Okay, so lastly is the notion of environmental, and this has been totally ignored, so I'm hoping everybody takes this home with you. The electricity demands for these very large data centers, computing, the transmission, and electric grid infrastructure. So at the same time, everybody's trying to put in an electronic infrastructure for air conditioning, for electric vehicles, and now at the same time we've got this huge demand over here. So where's all this electricity going to come from? Are they going to go back to oil because they can't produce it fast enough? Well, I guess here you could use solar, but not in Canada. It would be a dark winter. Heat generation is a big problem because these chips, including the NVIDIA, so they're using less electricity, but not enough. And so we need to look for a next generation of these chips that produce a lot less, use less electricity and produce less heat. So air cooling uses currently 40% of all the electricity used for these big computers. And so they've moved to water cooling, which seems like a great idea. But there's access to water problem globally, unless you're in the middle of a flood, like Toronto is today. But in general, access to water is not uniformly distributed across the globe. And so you say, well, it's cycled back. It's not a problem. But actually, the X there has not been filled in. 20% of all the water used actually goes off in moisture. It's given off in heat and the moisture, and then it affects the atmosphere, and it has a negative impact. So it is a problem. The material, which I think is a really critical problem, is that the cables, the fiber optics, the chips, the computer servers, everything uses copper, silicon, rare minerals, rare metals. And what happens when they go to the next little generation? Throw it away. So we have a really rare resource that's being used and thrown away. 12.5% of this rare material, metals and minerals, are actually just thrown out. And just a little reminder that toxic metals take millennia to decay. So it's not a matter of them decaying and make your soil better. They're just going to sit there in these slag heaps while we're going to let the next generation and the next generation figure out what to do with them. And last, which is the part that I work on most, is accountability. Who is actually responsible for harm that comes out of these? So there are harms to people and harms to the planet. I'll divide them in those two. Inaccurate results that may result in health or business or government access to benefits puts them at risk if they're not done correctly. False results are a big problem. And there are people, to be honest, working. There's a group in India and a group at the University of Waterloo who are actually trying to figure out algorithms that can go around and at least detect out-and-out false hallucinations. So there's some promise there. The biased data, I don't know what they're going to do with biased data, but something has to be done. And it may be that we need to have a beginning and end time, and we start throwing out some of the older stuff so that we have a chance of regenerating the big data sets with data that's less biased and more inclusive. And the violations of privacy and who owns the data was not resolved in the current responsible AI regulations and policies. It has not changed at all. In fact, I would argue that it's gotten worse. And now that the big companies are desperate for data and they're taking apart everything. So anything in social media, all that text is in there, even truth and social, whatever, everything is in there. And currently there's skewed benefits, right? So apart from getting a nice ChatGPT response, I don't know if there's anyone in the room who has gotten a real benefit from this. Right? So that's the hype part. Like, it looks good, it's great. But what is the use case for which this really will benefit people and communities, and how we're going to get there? The harms to planet, I'm just going to read this one quote. Unlike other interesting data industries, data centers are largely self-regulating. There's no sweeping federal agency to govern the siting and operation of new and existing facilities. Okay, have at it. Because really, that whole level of compliance and oversight has to apply to the new things, not just to the old things we know about, like oil fields, coal mining. They have these they destroy rivers and they destroy landscape. And so in the last 10 years, laws have come in to say, you did this damage, you pay for it. You restore this land and you restore these rivers. Okay. So this is about the governance piece. So we do have, as I showed you, a flotilla of regulations and policies around the world, but times are changing. Those are looking at it in the reverse mirror, where we are, not what's going to come. And how long does it take to get a new regulation? It takes years. Well, I don't know about India, but in Canada, it will take 6 months, a year and a half to actually update regulations and policies. And so what I'm out talking about is really, what are we thinking about? Size of data centers, harm to people, harm to the planet. And so what are the regulations as these things continue to develop, so that we've got regulations in place before we have full-scale problem here, so that people design things with these in mind. And my analogy is, when we talk about building responsible AI guidelines, it is exactly like trying to change the wheels on a car while you're driving, right? Because you can't stop it, but the car's going, AI keeps going. We need to figure out how to do that on the fly and to build regulations that are future-proof in some sense. It's not just this, if you do this, if you don't stop at the stop sign. And now as if you're, so now you've got a self-propelling driving car. Well, the current laws don't cover them, right? But they're going to be on the road. So how do we do that with responsible AI, with AI? Because it's moving. And compliance, we need to have laws that can be. So this is about the governance piece. So we do have, as I showed you, a flotilla of regulations and policies around the world, but times are changing. Those are looking at it in the reverse mirror, where we are, not what's going to come. And how long does it take to get a new regulation? It takes years. Well, I don't know about India, but in Canada, it will take 6 months, a year and a half to actually update regulations and policies. And so what I'm out talking about is really, what are we thinking about? Size of data centers, harm to people, harm to the planet. And so what are the regulations as these things continue to develop, so that we've got regulations in place before we have full-scale problem here, so the people design things with these in mind. And my analogy is, when we talk about building responsible AI guidelines, it is exactly like trying to change the wheels on a car while you're driving, right? Because you can't stop it, but the car's going, AI keeps going. We need to figure out how to do that on the fly and to build regulations that are future-proof in some sense. It's not just this, if you do this, if you don't stop at the stop sign. And now as if you're, so now you've got a self-propelling driving car. Well, the current laws don't cover them, right? But they're going to be on the road. So how do we do that with responsible AI, with AI? Because it's moving. And compliance, we need to have laws that can be enforced. We need to have certification processes. Important. We need some way of doing audits and understanding when we have it. So this is about the governance piece. So we do have, as I showed you, a flotilla of regulations and policies around the world, but times are changing. Those are looking at it in the reverse mirror, where we are, not what's going to come. And how long does it take to get a new regulation? It takes years. Well, I don't know about India, but in Canada, it will take 6 months, a year and a half to actually update regulations and policies. And so what I'm out talking about is really, what are we thinking about? Size of data centers, harm to people, harm to the planet. And so what are the regulations as these things continue to develop, so that we've got regulations in place before we have full-scale problem here, so the people design things with these in mind. And my analogy is, when we talk about building responsible AI guidelines, it is exactly like trying to change the wheels on a car while you're driving, right? Because you can't stop it, but the car's going, AI keeps going. We need to figure out how to do that on the fly and to build regulations that are future-proof in some sense. It's not just this, if you do this, if you don't stop at the stop sign. And now as if you're, so now you've got a self-propelling driving car. Well, the current laws don't cover them, right? But they're going to be on the road. So how do we do that with responsible AI, with AI? Because it's moving. And compliance, we need to have laws that can be enforced. We need to have certification processes. Important. We need some way of doing audits and understanding when we have it. Oop, talking too long. And enforcement. I get the part where you have the homework. Okay, going forward. So, I'm not sure what that line is. So these are the stakeholders. They're not the current stakeholders. The current stakeholders are almost entirely the suppliers. But if you look at the red circle, citizens, users, the data owners, and governments have a stake in this, each of those different units. In the more private sector, we have the suppliers, the algorithm designers, governments, and system developers. So they've been not engaged with responsible AI, but totally engaged with developing it. And so I want to know, right? That's you, and that's me, right? So we need to...
Thank you, Carolyn, for this wonderful talk. And also thank you, each one of you, the audience here, for making this a very interactive session. And I hope you take home the message that Carolyn wanted to convey.